going to give this a go. We're going to talk a little bit about rearranging equations and the language of mathematics. The language of mathematics consists of an unlimited amount of letters, but only 5 major pieces of grammar. And we all know what they all do and what they all mean. We can use the grammar of mathematics to change what the equation can tell us. So when I say to rearrange an equation or to change the subject of the equation, I'm asking you to use the rules of grammar and the letters in mathematics to make a new question that we can answer. So you've all seen something like this, I'm sure. A is equal to B multiplied by C. Okay, so what I've got there are 3 letters which can stand for any number, any single other letter in the mathematical language, and I got 2 bits of grammar. Now, the equals to sign just means that whatever number is over here, the number over here is the same. And we use the 4 different bits of grammar to explain what we have to do to these 2 numbers to get this number. However, in physics, quite a lot of the time, we're not able to find this number, so we have to find these 2 numbers. Or we're not able to find this number, so we have to use these 2 numbers, or this number, and we have to use these 2. We can rearrange the grammar to make it so that the subject has changed, the question has changed. Instead of trying to find A, we can now find B. But to do that, we have to change the grammar that we use. We have to change the operators. Now, the question itself would look something like this. If A is equal to B multiplied by C, I have A, which is 2, I have C, which is 4. Can you tell me please what B is? Maybe I found this by measuring it, and I found this by counting it, and I need to find out what this third factor is so that I can answer the question. I have to change the way that this question is being asked. Now I can't just do this, so warning, warning, this is not what you do. You don't just write it out by swapping the letters around. That doesn't make sense, and I'll show you why. We're going to give some numbers to these letters now. We'll say that this is 12, that B is 4, and that C is 3. 12 is equal to 4 multiplied by 3. 3 lots of 4 is 12. Or 4 lots of 3 is 12. So this is true. I can't change this equation by just swapping the numbers. 4 isn't the same as 12 lots of 3. 4 does not equal to 12 multiplied by 3. When we wrote B is equal to A times C, we did the exact same thing, because even though the numbers can stand for any number, the equals to always has to be true. So what do I do instead? What is 4 equal to? I can't change this number, I can't change that number, I can't change the equal to, and I can't change the 3, but I can change the operator. So I change the multiply for something that makes sense. Is 4 equal to 12 units take away 3? No, so it's not that. Is 4 equal to 12 units plus 3? No, that would be 15. Is 4 equal to 12 units divided by 3? Yes. If I split 12 among 3 different people, they each get 4. Now there's always a rule in maths, and all you have to do is follow the rules and you'll get the right answer all the time. Let's go back to the letters. We wrote down that B is equal to A times C, and I told you that that was wrong, and if I put numbers in, that shows that it's right. If I swap the multiply for a divide, then that's correct. B is equal to A divided by C. Now you'll have seen this in your maths lessons, but I'm going to show you 2 different ways that you can approach rearranging an equation. One is the proper way, and another is a trick way that gets you the same answer but without having to understand why it happens. Now if I want to rearrange this equation for B, I have to change the subject of the equation, and to do that all I have to do is make sure that both sides stay equal. The opposite operator to a multiply is a divide. So if I divide both sides by c, then that cancels out whatever I have done. And I'll show you that as an example. 12 is equal to 4 times 3. 12 is equal to 4 times 3. If I divide this side by 3, and I divide this side by 3, what have I got? Well, 4 times 3 is 12, divided by 3 is 4. 12 divided by 3 is 4. So it's the same thing, because I've divided both sides by, I've done the same thing to both sides, so the equals to sign is still true. Up here, I divided both sides by c. What I can do, I can just cancel out whatever term I divided by itself. And that's the same thing. 4 multiplied by 3 divided by 3 is still 4. B multiplied by c divided by c will be equal to b. On the left hand side, I'll have a divided by c. Now, some people don't like this. They like it to read like this. B is equal to a divided by c. But it's the same thing either way. 6 is equal to 2 times 3. 3 times 2 is equal to 6. The equals to sign goes both directions. Now, the trick way, if you don't want to go through this whole palaver, is to imagine or to remember that for any number that's written like this, you can also write it like this. A over 1 equal to b over 1 multiplied by c over 1. Any number by itself will always be over 1. Hello? Okay. Well, I don't know what I said. Okay, so any number by itself will always be over 1. What I can do is I can move these numbers from above the line to below the line and still follow the rules. The divided to sign, or the divided by sign, is just saying that I've got one number above the line and I've got one number below the line. Okay, so if you ever see something written like this, a is equal to b like that, you can also write a is equal to b like that. This divided to sign is just saying that there's one number up there and there's one number down there. 4 over 2 equals 2. 4 divided by 2 equals 2. It's the same thing. So I'll remember that each of these numbers is over 1. And if I want to move this, and again this is just the trick way because you're not moving anything, if I want to move this symbol and leave this symbol by itself, I can by simply picking it up and moving it over to the other side. But when it crosses the equals to, it has to go to the other side of the line. That's the same thing as saying a divided by c equals b, or that b is equal to a divided by c. Now I can show you this again using my little bits of paper that have spread out now. I shall have my a equal to b multiplied by c. Same thing that we had before. Remembering that each of these letters is over 1. I'm going to turn these around so that we can see the numbers, so that you can see that it's true, and then I'll show you using the letters. 12 is equal to 4 times 3. Now I'm going to move 3 over here, but because it can't go beside, it's crossed over the equals to sign and now has to go below the 12. That leaves me with 12 over 3 is equal to 4. We know that's true. Let's see if it's the same thing, if we can see that when we use our numbers, or our letters, pardon me. A is equal to b multiplied by c. I'll get my c, and I'll move it underneath my A because it's crossed over the equals 2 sign, and that will leave me with A over C is equal to B. Now if this is true, if what I've done is factual, then when I twist these numbers over, it should all make sense. So 12 divided by what is equal to 4. Okay? So you can do either one of these tricks. The moving one is especially easy if you've got something like this. D over E is equal to T. In this particular instance, you can just swap these. So it would turn into D over T is equal to E. Nice and simple. I moved D across and it went up to the top. I moved T across and it went down to the bottom. So, stay safe, and if you've got any questions, let me know.